Hello my dear students, I welcome you to the NEET world and this is our second lecture on mole concept. Okay, so in this particular video we are going to discuss about stoichiometry and its calculations and the next percentage yield, and we are also need to know about what exactly the limiting reagent and excess reagent, because this is one of the most important topic from this particular chapter. Okay, let us start our topic. Okay, so here what exactly stoichiometry? So we know in chemistry we used to write chemical equations, right? For example, A plus B giving rise to 2C plus 4D, we are writing something like this. Okay, we consider these are the reactants and these are the products. I think you know that this side is reactants and this side will be products, right? Okay, so here A plus B giving rise to 2C plus 4D I have written. So whatever the stoichiometric coefficients we are seeing here, so let us say here 1 and 1. So here 1 and 1, here 2 and 4, these are called as stoichiometric coefficients of respective reactants and products. Okay, so what is the stoichiometric coefficient of C here? It is 2, and for D here it is 4. So during a chemical reaction, the reaction takes place according to these stoichiometric coefficients only. So I can say this is theoretically 1 mole of A reacting with 1 mole of B, which is forming 2 moles of C and 4 moles of C and 4 moles of D. 4 moles of D. So based on this we have to do our calculation. Like if I want to find theoretically how much amount of C is formed, so I have to use this mole ratio so that we will be getting the answer. So this is how we will use to calculate theoretical yield, and experimental yield will be coming from like experimental like presentation. Like if you are doing some experiment, so due to some reasons it may be less than the theoretical yield also. Okay, that time so we have to take the ratio of those two and we can calculate the percentage yield. Okay, we will look into it after some time. Okay, here let me tell you one example. So here, before going to the next slide, so let us look into this definition first. What exactly the word stoichiometry means? So stoichio means it is elements, and metry means measure. So here how much, like elements measure, it means how much amount of this particular element is converting into some other form. So that is what we are calculating in this stoichiometry calculations. Okay, so it is used to calculate number of moles. See here 1 mole, I am saying 2 moles of product is formed and 4 moles of D product is formed, something like this. Okay, so we can give mole to mole ratio in this stoichiometry. So what I am saying, 1 mole to mole ratio, it means 1 mole of reactant giving some X moles of C, something like that we can relate, like mole to mole ratio, one thing. And the second thing is like weight to weight ratio. It means like 5 grams, like 5 grams of A is reacting to with B to give some 10 grams of C, something like that. Okay, so we can relate weight to weight also. And the third one is volume to volume also we can interlink. Okay, like 5 volumes of A is reacting with 3 volumes of B and forming some 6 volumes of C and 5 like some n number of volumes of D, something like that we can interlink. Okay, so we can interlink this also, like mole to weight also we can interlink. Okay, let us see some example that will give you more clarity. So here let me take one example. Here N2 plus H2 gives rise to NH3. So first of all you need to balance this reaction. Okay, so here 1 mole of N2 I have written. So here I am writing 3 moles of H2 and forming 2 moles of NH3. So write the mole ratio of reactants and product. So 1 mole. See whatever the stoichiometric coefficient, like what is the stoichiometric coefficient of N2? It means what is the coefficient of N, like nitrogen? Here it is 1. So I am writing like this. So for it is 3 and here it is 2. Okay, this is what the mole ratio as per the balanced chemical equation. Now 1 mole, this is 3 moles, this is 2 moles of product is obtained theoretically. Okay, so now instead of writing 1 mole, we can say what is the molecular weight of N2? That is 28 grams now. So we can write 28 grams also. Instead of writing 3 moles, we can also write it as 3 into what is the molecular weight of H2? it is 2. So we can write 6 grams also. And for this 2 into for nitrogen it is 14 plus 3, that is 17 grams. So we can write it as 34 grams also. It means for every 28 grams we require 6 grams of H2, that will give us 34 grams of ammonia. Okay, so here one thing you need to understand that, see here the total, what is the total mass of reactant side? 28 plus 6, so total is 34 grams. So total mass of reaction is conserved. See, the law of conservation of mass is obeyed by this particular reaction. See, reactant side and product side total mass is like same. Okay, so total mass is conserved, we can say, but number of moles may be different. Okay, this you have to be keep in mind. So during a chemical reaction, total mass is conserved. Okay, now here if sometimes instead of giving 28 grams, if you are provided only with 14 grams, so what happens to the amount of product? So this is the question I am asking. So given, what is given? Given only 14 grams of N2 and 6 grams of H2 is given. So what is the amount of product formed now? So what is the amount of ammonia yield or produced as per the given equation? So how do we calculate? See, for every 28 grams of N2, 6 grams of H2 is reacting and forming finally this much. It means for every 6 grams, how much amount is required in order to make the reaction complete? So it will be 28 grams is required, but we have provided only 14 grams. It means for 6 grams we required, definitely it should be 28 grams only. If it is lesser than that, it means the required amount of N2 is not there to react completely for this H2, right? So for this 6 grams we have only 14 grams. It means, can I say this is lesser than our requirement? So whatever the quantity less, that reactant can be considered as limiting reagent. Okay, so because we required for every 6 gram we required 28 grams, but we are provided only with 14 grams. It means it is lesser than our requirement. So we can say that particular thing as limiting reagent, which I am representing as LR. And see, it means our calculation, whatever we are doing, that calculation must must proceed with the limiting reagent only, but not with the excess reagent. It means for every 28 grams, how much hydrogen is required? 6 grams is required. It may so now as per this equation, if we consider, so for 28 it is 6. It means for 14 it should be how much? It should be how much? See, it is half. Then this should be also half. It means only 3 grams is enough. 3 grams is enough, right? See, from here to here it is 14 grams. Here also you just do half of it, so it should be also 6 grams only. Okay, so this is out of 6 grams. We are in the reaction, we are reaction is consuming only 3 grams, and remaining 3 grams will be remained unreacted. This 3 grams will be what? Remained unreacted. Remains unreacted. Reacted, we can say. So now this is remaining unreacted, no? So we can call it as excess reagent. ER I am writing. So for 14 grams we require only 3 grams, but we have 6 grams. So remaining 3 grams will be remained unreacted. We can call it as excess reagent. Okay. So what I told you, in stoichiometric calculations we have to follow our calculation with respect to limiting reagent only. Now I am asking how much amount of product is formed. Okay. For 14 grams, how much it is reacting? 3 grams. Therefore 14 plus 3, it will be 17 grams. Okay, I hope this is clear. Our calculation should be must done with respect to limiting reagent only. So here the overall resultant will be like after completing the reaction, is there anything remaining from N2? No, this is 0 grams remaining. Okay, how much it is remaining? 3 grams remaining. Okay, and what about how much amount of product is formed? 17 gram is formed. This is what the remaining amount after the reaction. Okay, in the reaction mixture, if you consider, this will be the remaining. Okay, now here I hope that limiting reagent, excess reagent concept is clear. Let us look into it with one more example. Okay, so here I have provided the definition and all. Okay, see, here I am taking H2 plus O2 giving rise to H2O. First of all, balance this equation. So H2 plus O2 gives rise to H2O, means let us say here it is 2 and here also it is 2. I hope it is balanced. Okay. So now 2 moles of H2 reacting with 1 mole of O2 and forming 2 mole of H2, right? So 2 moles of H2 reacting with 1 mole of H2 forming 2 moles of H2O. This is as per the equation I have written. Okay. Now if in the given question, if a question is given, if 2 moles of H2 is also given in that question, for example, if a reaction given, if in a reaction, let us consider, if in a reaction, consider 2 moles of each H2 and O2 is given. 2 moles of each H2 and O2 is given. Then they are asking how many moles of H2O is formed. So in the given reaction, they have provided with 2 mole of each A and B, like H2 and O2, and what is the number of moles produced, H2O produced, they are asking. Okay, and also identify limiting and excess reagent. See, as per the equation, as per the balanced equation, for every 2 moles of H2, we are required 1 mole of O2. It means here also for every 2 mole, see anyways they given 2 moles each, but in this also for every 2 moles, how much amount of O2 is required? We required only 1 mole is required, right? So it means out of these 2 moles, 1 mole is used for reaction and 1 mole remain unreacted. So I hope you got which is limiting and which is excess now. So this is completely reacting, but out of these 2 moles, 1 mole is reacted and 1 mole is remains unreacted. It means this can be the excess reagent and this will be our limiting reagent. And now how many moles of product is formed? I already told you how do we calculate. We have to calculate our amount of product formed with respect to limiting reagent only. It means this is our limiting reagent now. See, for every 2 moles of limiting reagent, product is 2 moles. Here also for every 2 moles it should be also 2 mole. I hope this is clear. Okay, let us look into it with one more example. Okay, so here I am giving you. So now tell me what is the resultant mixture we have. So this will be 0. Always limiting the amount of limiting reagent remained in the reaction will be 0. It will completely participate in the reaction. It will be completely over. Okay. So now, but excess reagent here it is left is 1 mole. And how much amount of product is formed? 2 mole. I hope this is clear. Okay. Okay. Let us see few more examples. Okay. So let us solve this question. The mass of assertion. Here we have a question with us. So what is the question? Here they mentioned assertion is the mass of products formed in a reaction depends upon the limiting reagent. Yes, right. Okay. Reason: the limiting reactant reacts completely in the reaction. Yes, it is reacts completely in the reaction. No? So what we can say, both assertion A and R. Assertion is A and reason is R. Both are true, right? And R is correct explanation of A. So option A is correct. Okay. Then next, what about this percentage yield? Okay. So during some chemical reaction, what happens? See, theoretically, whatever we have did now here, whatever we have studied theoretical calculations. So if we are considering or if we are comparing this with the practical experiments, so all the time the practical product formed in the practical reactions, if we are doing practically, the amount of product formed or amount of yield obtained in the practical in the real sense, it will be always lesser than the theoretical one. Okay, so always actual yield or experimental yield, I can say always experimental yield will be lesser than our theoretical yield. Okay, so in our daily life also we know that reality will be always lesser than the what we expect, right? This is how life goes on, right? Okay, so actual yield or experimental yield will be lesser than the theoretical yield. So that is why we need to calculate percentage yield in order to express how much quantity we are obtained when we compared with the theoretical one. Okay, so here you can read this, whatever I explained, it is written over here. Okay, so how do we do this? How do we do this kind of questions? Let us see. Okay, let me give one example. Okay, so here let us take one question like 2a plus 2b giving rise to c plus d. Okay, d plus d. Okay, so now for this particular reaction, if 4 moles of A and B are given, then only half mole of D is formed. C or D is formed. Then what is the percentage of yield? What is the percentage of yield? See, look at this question. Just now I have created over here just to make it very simple. See, 2a plus 2a plus 2b giving rise to c plus d is the question they have mentioned. This like this they may mention. And for this particular reaction, now they are providing us 4 moles of A and 4 moles of B. And if they do this reaction, they got only, practically if they do experiment, they got only 0.5 moles of product. 0.5 moles of product is obtained. Then what is the percentage yield they are asking? So it means we need to calculate what exactly the experiment like theoretical yield, and we have to compare both of these. Then therefore we will be getting our final answer. See here. So for this particular reaction, let me select. Okay. Okay. 2a plus 2b gives rise to c plus d. They have given this equation. So now here, what is their mole ratio? 2, 1, 1, right? So this is how their mole ratio is given in the question. Okay. So for every 2 mole, we are getting 1 mole. It means for every 4 mole, given 4 mole. For every 4 mole, it should be how much? See, for 2, it is half. It means 1. For 4, it should be 2 and 2. But how much they are getting? 0.5. So it means what is the theoretical yield? It is theoretical yield is 2 moles. But practical experimental yield is actual or experimental yield is how much? 0.5 mole. So therefore we can give the formula, we can use percentage yield equals to experimental yield, see actual yield or I can say experimental yield. How much that is? 0.5 by what is the theoretical yield? That will be 2 into 100. So how much we are getting here? So we can say this as 1 by 4 into 100. So this will be 25%. What is the percentage yield for this particular reaction? That is 25% only. Okay, I hope this is clear with this small example. Okay, now tell me for this reaction, see this is a PYQ question again. Okay, the number of moles of H2 hydrogen molecule required to produce 20 moles of ammonia in Haber's process. So what is the Haber's process? We can write it as N2 plus H2 gives rise to NH3. So balance this equation. So here we can say 3, 2, 1. 1, 3, 2 is the mole ratio. So the number of moles of H2 hydrogen molecules required to produce 20 moles of ammonia. See, they are asking relation between these. For every 2 mole we required, how much we required? 3 moles. For every 2 mole we required 3 moles. Since they are asking for 20 moles of ammonia, so just multiply with 10. So here just from here to here, what is the change? Multiplied with 10. So here also you just do the same thing. It means how much it is? 30 mole. So what is our answer? 30 mole. Similarly, you can tell me for how many moles of N2 is required for this particular question they ask. So please let me know in the comment section about this. Okay, so it's done with this chapter, and this is very important parts like part 1 and part 2, and we will be doing some more questions based on this and based on your response. Okay, so do more practice, and you can ask me if you have any doubts in the comment section. This will be very helpful for your NEET and upcoming EAP set also. Okay, thank you for watching. Keep smiling and happy learning.